Hi everyone, how are you? So today is big day because this is the big picture. Today's lesson is actually all of those little skills coming together in one lesson. What is that lesson? What is that topic, you're wondering? Solving trig equations. Woohoo, we made it. Even though we're not together, we kind of really are because you've been working really hard and we're here. We're solving the big picture. I'm so excited. Okay, so today's objective is to solve for x, angle x, on the interval. Can you see it here? 0 is less than or equal to x, which is less than or equal to 360. So you're solving for all angles from 0 to 360 degrees. If needed, round to the nearest tenth. So this is the sine function. So this is your very basic type of equation. It's saying sine x is equal to radical 2 divided by 2. So basically what we're trying to do is we're trying to find the y value when the coordinate on the unit circle is radical 2 over 2. Or I should say a circle. So what you do here is, because the function is already isolated, go to your calculator and hit second sine, that's how you find an angle, radical 2, so second x squared, divided by 2, oops, sorry everyone, so radical 2 divided by 2, and gives you 45 degrees. So that's it. That's the answer. As long as your function is isolated, is by itself, you're good to go and put that in the calculator. And don't forget, when you're trying to find the angle, you hit second button and whatever this is, sine, cosine, tangent, and type that number in. So the thing is, our answer is 45 degrees, but we're told to find the answer from 0 to 360 degrees. So we have to find all possible answers. So if you guys would notice, this is a positive angle and it's acute. It's less than 90 degrees. So this, everybody, is the alpha, is your reference angle. Remember, your reference angle is always a positive acute angle. So you have to think to yourself, which quadrants can I work in? Look at the next thing we're doing. So sine is the y value, right? And we're given a positive value of radical 2 over 2. So y is positive in which quadrants? So this quadrant goes plus plus, this quadrant goes minus plus, this quadrant goes negative negative, this quadrant goes positive negative. This quadrant is quadrant 1. Every coordinate goes right then up, positive positive. This is quadrant 2. Every coordinate here goes left up, which is negative positive. This guy's quadrant 3. Every coordinate in this quadrant is negative negative, so left down. And this is quadrant 4. Every coordinate in this quadrant is positive negative, right down. So with that said, if y is positive, broke my pencil point. If the y value is positive, we could be in quadrant 1. If the y value is positive, we can be in quadrant 2. The y value is negative here, so I'm going to get dramatic and cross that out. And the y value here is negative, so I'm going to get dramatic and cross that out. If you would notice, your reference angle fits in the first angle, in the first quadrant. So 45 degrees is one of my answers. So now I need to find the angle that is in the second quadrant whose y value is radical 2 over 2. So always, always when you're trying to do this, you take 180 degrees and you subtract the reference angle, which is 45. Now why do you do that? The second quadrant makes 180 degrees, makes that straight line. So any angle in this quadrant has to be less than 180. So it doesn't come from this random number. It's actually because it's a straight line and every straight line is 180 degrees. So when you take the difference there, it's 135 degrees. Guys, we did it. We just solved this. The sine of x equaling radical 2 over 2 would be 135 degrees and 45 degrees. That's the big picture, everybody. All those annoying things that you had been working on, this is it. Of course, they're going to get more complex, but there's your basic kind. So I know your head's probably spinning, so let's just keep doing some more practice problems. Okay, write down all the notes that you have. Stop, pause the video, go back to see what I've been saying if you need more clarification on something, okay? But we have 4 examples we're going to do together. Okay, so the next one, cosine 2 times the cosine of x equals 1. So like we said in the first one, you want the function, the sine, cosine, tangent, to be by itself. So in order to do that, I have to bring the 2 to the other side by dividing it, because that's the opposite operation. So now I have the cosine of angle x equals a half. I'm back to, like this guy, the function being by itself. It's isolated. So now in the calculator, I am going to hit second cosine this time. 1 divided by 2, 1/2. And the angle is 60 degrees. So I am going to say the angle is 60 degrees, and because it's positive and acute, that is my reference angle, my alpha. So that's the angle that I'm going to use to find every angle. All right, so now you have to figure out what quadrants we can work in. Recall that cosine is x, and it's a positive 1/2. So x is positive. Now we have to figure out when x is positive in the coordinate plane. So does everyone agree x is positive in the first quadrant because it's positive, positive? Second quadrant goes negative, positive, so x is negative. So I'm going to get dramatic and cross that out because that doesn't match up. We need a positive. The third quadrant goes negative, negative. X is negative here. I'm getting dramatic and crossing it out. And then the fourth quadrant goes positive, negative, x is positive, cosine is positive. So these are the 2 quadrants that we're going to use. So at this point, I want everyone to notice you're always working in 2 quadrants. You're never going to use all 4 at a time for one individual piece like this. So you're always going to be crossing out 2, which is what that little skill that you were doing, trying to find the angle of, the quadrant for which the angle terminates. Okay, so quadrant 1 is the acute angles, right? And 60 degrees is what we got as our reference angle. So that one fits in there. Again, we got lucky again. Doesn't always happen that way. Now we have to figure out the angle that fits into the third quadrant. If you guys would notice, it's getting very close to 1 full rotation, right? This is 90, 180, 270. So between 270 degrees and 360 degrees are all the angles in the fourth quadrant. So to figure out the angle that falls here, it's 360 minus 60, and it's not random. Again, you're always working off of the x-axis, so you're either adding or subtracting 180 or just subtracting the 360. So your 2 answers here, that's an ugly 3, are 60 and 300 degrees. If you type into your calculator the cosine of 60 degrees, oh my gosh, you get a half. If you type in the cosine of 300 degrees, I am in shock, you also get 1/2. So that's an excellent way of checking your work. Okay, so those are our 2 examples so far. Here you go. Now we are going to get into 2 more examples where you have to isolate the function, sine or cosine, a little further. Okay, so let's get that done. So for example 3, if you would notice, 4 times the sine of x minus 8 equals negative 10. I want to get this whole word by itself, the function. So first thing is first, like a regular 2-step equation, cover what you want to isolate. So first you want to add the 8. So it's 4 times the sine of x equals negative 2. And again, this is 4 times the sine of x, so the opposite operation is 4. So you have negative 2 divided by 4, which is really negative half. Mission accomplished. The function is isolated. It's by itself. So now in order to find that angle, you hit second sign in your calculator. When you want to find an angle, you hit second button and then whatever it is, sine, cosine, tangent. Type in -1/2 and you get -30. Okay, so your angle is -30. Now this was one of the skills that we learned way back when in March, that if you get a negative acute angle, its reference angle is the positive version. I promise you, we discussed that. If it's a negative acute angle, you just make it positive, all right? So your alpha, your reference angle, is 30 degrees. So now, you have to figure out what quadrants you'll be working in. And how you do that is you work off of this information. The sine is -1/2. So sine is y, so y is negative. So now you have to think to yourself, in the coordinate plane, where is the y value negative? Okay, so hopefully everyone agrees these guys are gone because the third quadrant goes left and down and your y value is a negative. And hopefully everyone agrees that this quadrant, the fourth quadrant, goes right then down and again your y value is negative. So that's how we're picking the quadrants here. So if you'd notice, our reference angle of 30, that does not fit into either of these quadrants. So in order to figure out the angle in the third quadrant, you're working off of this line, this 180 degrees, right? So does everyone agree that you're exceeding 180 degrees here? To exceed means you add to 180 degrees. So 180 plus your reference angle of 30 is going to give you 210 degrees. Then, we just spoke about finding the angle in the fourth quadrant, so it's going to be 360 degrees minus the 30 reference angle, so it's 330 degrees. And again, a nice little check method is going to be typing in, where is it? Right here, your isolated equation. Sine of x equals -1/2. So x is what we solved for, so x is 210. So type in the sine of 210. Look at that, -1/2. We did it correctly. And if you type in the sine of 330, look at that, -1/2. Okay. So then our last one. Our last one is a cosine equation where it's the same thing as number 3, where we have to isolate the function. So you want to get this guy by itself. So in order to do that, you subtract. So you always add, subtract before you multiply, divide. It's literally the same rules of what we've been doing for literally every equation, pretty much your whole life. You add, subtract before you multiply, divide to isolate the term which you're trying to solve for. Then you divide by 5. This is just a very complex equation. These are like, I'm so excited. These are big time. These are really, really fun ones for me. This is the big picture. So we are getting the cosine of angle x equals -4/5. In order to find that angle in the calculator, hit second cosine, -4 divided by 5. Okay, so in the directions it said round to the nearest tenth if necessary, so we will do that. It'll be angle x equals 143.1 degrees. So this is not our reference angle, everyone. Our reference angle is always a positive acute angle. So the calculator didn't give it to us, so we have to find it. This is also one of those other skills that you learned. In order to find the reference angle, what you do is you think to yourself, what quadrant is this angle in? And hopefully everyone can visualize that this is in the second quadrant. So in order to find an angle in the second quadrant, it's always 180 minus 143.1, or 180 minus whatever the angle is. So 180 minus 143.1. So your reference angle is 36.9 degrees. So we're getting to the point where the calculator, the problems are working out that you're not getting the information right away. So if you're not getting a positive acute angle first, you have to go and find it. So you had an extra step in this problem. Great. All right, so now you got to figure out the quadrants you're working in. Okay, what are we doing here? The information of which to figure out what quadrants you're in is when you've isolated the function, sine, cosine, tangent. So cosine, which is x, is a negative number. So x is negative. Put that in there. Where's x negative? So think about it. Can't use this quadrant, it goes positive, positive. X is positive. You can use the second quadrant because in the second quadrant you go left up, so x is negative. And you can use the third, what is with me in this pencil today? Sorry. You can use the third quadrant because x is negative over here as well. So fourth quadrant's out because the fourth quadrant goes right then down. Check it out, x is positive, we don't want that. So we're working in the second and the third quadrants. Please notice your angle that your calculator gave you was one of the answers. 143.1 fits here into the second quadrant, right? Because an angle that's 143 degrees is like there-ish, right? A little bit more than halfway. So the 143.1 degrees, that was easy. That just goes right there. The third quadrant angle, you need to use your reference angle. So you've exceeded 180 degrees, so 180 minus the 36.9 degrees. Anyone notice my pencil point broke again? 180 minus the 36.9 up, excuse me, I said exceed. Hello. Exceed means to add, everyone, yes? So it's 180 plus. So it's 216.9 degrees. Okay. And those are the two answers. So at this point, I just want to make a note with everyone. If you're trying to find, I need a piece of paper, hang on. Okay, if you're trying to find the angle that's in the second quadrant, it's always 180 minus your alpha, your reference angle. These notes are in your lesson, but I just want to reiterate this. It's always nice to see it at the end of the lesson because it makes more sense. If you're trying to find the angle in the third quadrant, it's always 180 plus your reference angle. And don't forget your reference angle is the positive acute angle. And in order to find the angle that lies in the fourth quadrant, it's 360 minus your reference angle. And the answer that's in the first quadrant is the actual reference angle, the positive acute angle. Please notice you're either adding or subtracting from 180 or 360. So it's just subtracting from 360. You never use 90 or 270. Okay, so this was our first lesson on solving trig equations. These are the simple ones. And do your best, ask me questions, pause the video, do whatever you need to do to help along with this. Okay, I miss you. I hope all is well. Don't hesitate to ask any questions. Message me, email me, whatever you need. Bye, guys.